All right. Hey, everybody. We are Third Derivative. We are back with our Lab 7 demo. Before we jump into that, just very quickly, we wanted to run through our documentation at a high level. Again, if you want to see this in detail, it is available on Coursistent. Um, so this lab it was a lab on IoT systems. So we were getting to experiment with something new, which is physical data movement. And we thought it was really fun to turn our mobile devices into IoT nodes, which could communicate with Thingsboard IoT, which we hosted on AWS. Um, we had a lot of fun like collecting the data and seeing the places that we visited over the last few days. And we also learned a lot about protocols like HTTP and MQTT, and how we can look at things on Thingsboard. This lab also kind of asked us to look into what is IoT, which stands for the Internet of Things, where physical devices can communicate, share data, and enable automation. Um, Essentially, at a high level to set this up, we had to use OwnTracks. This is the app which Dr. Cho showed us, which can turn our phone into an IoT device. And we configured it in HTTP mode. Um, we set it up so it automatically transmits our location and sensor data. We hosted it on AWS, and this involved us having to install OpenJDK and PostgreSQL as our database. Um, we had to create devices on Thingsboard, so we logged into Thingsboard and we had to generate the unique token and a telemetry HTTP endpoint. We built the IoT dashboard and we added like a map widget so we could see the locations on the map. And then basically we ran into some challenges and did some troubleshooting. This included things like fixing the security groups, dealing with authentication, and learning more about the connectivity. In the future, we think it would be cool to do things like add sensor fusion and explore multi-user dashboards. And we overall just had a really great time using data analytics and infrastructure and looking at real-time data and transmission protocols and cloud visualization. Um, Also, at this lab, we did take advantage of fall break. So some of the cool things that we did actually were meet up in Santa Monica this time. And we worked in cafes and we also visited the beach. Just because since we are tracking our location, it would be fun to add somewhere cool in Los Angeles to our database. And we also celebrated Steve's birthday at the Cheesecake Factory. With that being said, I'm going to pass the floor to the rest of my teammates so they can talk a little bit more about what we worked on this weekend.
All right, cool. Um, there's a lot of stuff to begin with, but let's start with like EC2 and how it's supposed to work. So I think I should preface this by saying a life lesson that if you if you can waste money, I'm sorry, if you can spend money for the better, you probably should. And um, this was exemplified through the fact that we're using T3 medium. And I can tell you that T3 small and T2 tiny initially were not great. We spent like 3 hours waiting for like even just installing MySQL to work because yeah, you have to install MySQL before you do anything else. And we just sat there at a cafe being like, yeah, cool. It's just gonna take 3 hours. And yeah, we ended up swapping to T3 medium, probably something to know for future labs. Otherwise, uh, it's not too like different compared to how we did um stuff in the lab. Although, can you scroll down? So go to security. I think something we added is there's a security button. Yeah, so scroll down. So we also had to open an 8080 port. This is for things for yeah, nothing special. Uh yeah, that will be all. I'll share my screen too. So post office. Oh, give me a bit. SH, five of them. Oh, sorry. Hmm, that's right. So um this is just the login details for our EC2. I'm, I'm trying to find the so we ended up having to use a Docker. Um, I'm trying to find a way to explain this without because this is a bit tricky. So initially we were following the lab, but then we opened the ThinkSport IO link, and within the docs, like they recommended using a Docker. So we just ended up using the Docker ourselves. Like so this is the code that we were supposed to use to create the Docker like file, the Docker environment. Well, container is the word. Uh, we would create. This is just opening certain ports, and this is just getting everything from the ThinkSport page. I'm actually not too aware of what I did hmm, because I literally just copy pasted this from the website itself, but it created like a separate ThinkSport uh it created a separate container with which we can use this. So I'm surprisingly tired today. Sorry about that. Mm, so that's how we got ThinkSport to work. Nothing too interesting. Give me a bit as I try to find
Yeah,
the ThinkSport page. Yeah, sorry, I'm a bit too tired today.
it's fine.
Um, 191, 68, 68, 80. Oh, mhm. There we go. So that in turn gives us ThinkSport, um, which is here. Nice. Uh, uh, my end key is also not working. There we go. So here is the ThinkSport dashboard and everything else. We started by creating devices. Why is this one inactive? Um, the data is currently updated, I believe, every 5 minutes. But I mean, we just created a new device and um got this link, and at this is the HTTP which we will be using for our own tracks, I believe. So, so going to own tracks, this is so as you can see, the parameters are here, and we went to settings and changed several things, but basically we swapped the mode to HTTP. We put our user ID and HTTP here, and we changed a few things like locator displacement and locator interval, which means because we're on move mode right now. Move mode means that it will always update for every 300 seconds or every 10 meters move. So whichever comes first, of course. And everything else is not as necessary, I believe. Ranging helps when you do when you're in the building and you would like to use Bluetooth. And everything else is not as necessary. Pub retain is slightly helpful, but nothing important. And so this data uh gets fed once again. Uh gets fed here where you can see the latest telemetry. So for example, if I force sun location now, there it's literally instant. So we see like the new changes that just happened like right now. We can also conveniently include images if we want. This is this is something we haven't had a chance to figure out yet. So we got all three devices on. Um, all three of them should be running. I believe Nerali set her to either manual or quiet, which
Yeah,
is why I said inactive,
yeah.
which is fine. That's when you don't want other people to see your stuff. And now we have something like this. Uh, we use like three map types. This is by default, and we just added the latitude and the longitude. The longitude, I can't spell. The longitude of our three iPhones. And we added a few more things here and there, but nothing interesting. It's just to show our locations. Technically, we also docked ourselves. That will be fine. And I believe that was it. But before that, I should also show one more thing, which may or may not help with how we're doing stuff. So, well, it will help with how we're going to talk about the Python script later. So we haven't really had enough time to dive into how we can utilize like live data with Postgres yet, but what we can do is we can get the data like this, which gives us all of the, you know what, I'll just show. Uh, mm, well, I name it new file name, so it will be new file name. Yes. Wow, that's a lot. And one moment. MNCC user um, oh, that was smooth. And so, and this is what we have at the end. Uh, we get our name, we get names, keys, the timestamp at any given time. So um, this can go up. So this will be the timestamp at when the data is sent, and these are just like the outputs. Where it's like so these are string outputs. This is like the long like integer output, and this is double output. And like I said, my keyboard and button is completely broken, so sorry about that. But for every like timestamp, we can see some keys. The other one I don't really recognize, like in regions. I believe this is with respect to waypoints, latitude and longitude. Longitude is probably somewhere here. SSID, I'm currently at Lorenzo, so you see like the Wi-Fi name and then the IPv6, I believe. That looks like IPv6. And then some more locations and just longitude is there. Battery info, I'm at 80%. So this data will most likely be fed later on to our Python script, which we created later on. And we also do plan to use like this data set effectively from within Postgres itself. But it was easier to extract it to see what happens and then to decide on what to do next. And I believe that's most of what we do. It should be most of what we do with respect to own tracks. Let me see if there's anything else. I don't think I missed anything else, yes? Yeah, because as far as I checked, that's pretty much everything. Oh, a couple of things to note at the end. Um, this is more implementation based compared to what we will describe in the documentation itself. But first of all, like I've mentioned, and now I should pull up the Salesforce doc itself. The key, please work. One second. So first of all, if we go to not the website, but to a documentation, uh, apparently I can't even remember what it was. Good. But first of all, like first thing to note, we use a Docker method, which is somewhere in ThinkSport. I'll find it later. Secondly, you always want to ch mod 600 or 400 your PEM file. I don't think this was mentioned. This is because otherwise Amazon will complain that your permissions are way too open and will reject the connection. Uh, Certainly, like I said, use use a medium version because otherwise, you only have like 1 GB of RAM. And during our running, we realized we already used up to like gigabytes of RAM. Like by the time we opened up our like ThinkSport um dashboard, so that says a lot. Force don't bother instance connecting. It always crashes. At TCP port 8080. And I guess last thing, always remember to log in as tenant at thinkport.org instead of sysadmin.think like at thinkport.org because only the former can add devices. The latter does something else that I'm not aware of. And I believe that should be all.
Okay.
Yeah, you
Okay.
can go for it.
So yeah, so I think this project helped us understand the use cases that could occur if we have our phone as a GPS. So for instance, because most people have their phone with them everywhere they go, so it could be used if someone steps out of their house and they want their lights to automatically get closed, so it could like help in that case. Or so our project used it for example tracking. So when a person goes out of the house after 7 p.m. and then comes back, so it will send emails to whatever friends that they have added to their contacts that they have arrived home. So that's what our project allowed. And I'll just share the Python script for how we did that.
Nirali, if you're talking, you're muted.
Okay, could you hear me? Up till now, was I muted?
Yeah, I think when you started sharing screen, you were muted.
Okay. So yeah, this is the script for, notifying our friends when we have come back home late. And so basically, if I wanted to notify my friends, so basically I had to um input my home latitude and longitude location so that we could locate when I'm away from home and when I'm back at home. And so basically that's what this is, my home's latitude and longitude, and then the radius, how much is counted as my home, so about 120 meters around. And every 30 seconds it's going to see the location of my phone if it's away or at home. And basically we have used Gmail to send the email to the friends to notify them. And so basically this is the first function, send email, that uses Gmail to send the emails to the friends to notify. And this is another function. So it uses haversine distance, which basically is used to calculate a circular distance using the longitude and latitude between 2 points. So that was really interesting. And so basically, this calculates the distance between 2 points when we have the latitude and longitude. So it helps us to know if we're at home or away from home. And then we have so that data, so wherever I'm going, it's storing the latitude and longitude of my phone. So that is stored in the SQL database. So first, this function is just querying the database to check every 30 seconds where I'm at. And yeah, so this is now, these are just different functions. So if I'm at home, so it should be within the home radius if we query from the database. And yeah, so it will send these emails at home or left home after it has calculated the distance between the home latitude, longitude, and where the real time latitude and longitude is. So yeah, this is how the script works. I could quickly share the emails that I got. Let me just stop sharing. Yeah, so as you could see, this is the email that was sent when I was away from home. So that means it's notifying my friends that I left home. This is, yeah. And then once I reached back home, again, it sent an email. So, yeah. So, yeah, that's what we used our project for. Yeah.
Oh, yeah. Can you go back to the Python? I feel like because we didn't have time, like
The
so.
script.
Yeah. So we worked a bit on this, and there were a few things that definitely we can do better. Just kind of want to point that out because otherwise it would be complete, you know. Uh,
Okay.
yeah. Can you scroll up to the top? So, uh, first of all, we would. So this config is currently only done for Neurali, and like us two can do the same, but the bigger issue is we can't effectively use this without like building a whole config system, whether that's through CLI or through an app interface. Like this is probably not as optimal. And secondly, as you can see, there's a time zone offset minute, which is explained. It basically just means how many minutes were off, right? And currently is still for we still have to like write it down for PDT and BST. But in the future, if possible, we would like to use public services to determine where we're at and our time zone, which then we can like reverse use for uh our work for other customers. And there are a few other things here and there, but those two would be the main concerns I currently have. Um and yeah, that's all I believe. Like the code itself is quite self-contained otherwise.
Yep. All right. Yeah.
That should be all.
Yep. So thank you so much.
Thank you.
And yeah.